All right, let's say we have f of x equals 4x minus 3 over x squared minus 9. All right, what do you got there for your vertical asymptote? Same thing, vertical asymptotes, denominator equals 0. Well, in this case, denominator is x squared minus 9. So it said x squared minus 9 equals 0. And if you want to do that one, square root method, add 9, square root both sides. The only catch is it could be plus or minus square root of 9 sides, so that's plus or minus 3, isn't it? So we've got x equals 3 and x equals negative 3. Both are vertical asymptotes. So I've got two vertical asymptotes here. Negative 3 and positive 3. So a graph, a rational function, can have more than one vertical asymptote, and this one does. All right, horizontal. Again, two ways we can look at it here. If we do the y equals a over b thing, though, what do you got? Well, the thing of it is, I've got x squared on the bottom. What about the top? Well, the top only has x, and so if I want to do the a over b thing, I need an x squared to match it. What would wouldn't that be 0x squared? So they'll cancel. So again, I get 0. Another way you can see it, the way the book does it, is say, well, I've got the numerator degree is less than the denominator degree. And always, if that's the case, the horizontal asymptote is 0. Either way you want to look at it there. You've got y equals 0 as your horizontal asymptote. So it's going to level off y equals 0. Okay? All right, let's do the intercepts. The y-intercept is set x to be 0. 4 times 0 minus 3, 0 squared minus 9. Hey, that's 0, so that's negative 3 divided by negative 9. That is reduced to be positive 1/3. Positive 1/3 is the y-intercept. What about the x-intercept? Well, the x-intercept, you said f of x equal to 0. And to solve that one, multiply both sides by the x squared minus 9. So it'll cancel out on the right. Zero times anything is 0, so we've got the left side is 0. 4x minus 3 is the right side, so all I have to do is solve that. Add 3, divide by 4. 3/4 is x. X-intercept. So I have my x-intercept's 1/3. My y-intercept's 1/3. My x-intercept is 3/4. Put those up here. Here's 1, so 3/4 y-intercept. Whoop, I did it again, didn't I? 1/3 is the y-intercept. 3/4 is the x-intercept. So those are right there close together. 1/3 for the y-intercept, 3/4 for the x-intercept. So, which doesn't look like much to go on. So that's why I say let's do a couple other points. Tables with x values around the vertical asymptotes. And since we have 2 here, we might need a few points to go off of. All right, so I've got one x-intercept's negative 3, so let's do a couple around it. How about negative 4, negative 5? And then negative 2 and negative 1 on the other side. Maybe it won't take too much there. Here, this one, let's do 2, and how about 2 and 4 and 5? Since I've got some close over here, you could do some more if you wanted. But so yeah, a few more points because I've got more vertical asymptote, one more vertical asymptote there. I don't think it'd be too bad if I do that. All right, let's see. -5, we've got y. What would the y value be? It'd be negative 20. 4 times -5, be negative 20, minus 3 over. Let's write it down. 4 times -5, minus 3, and then -5 squared, minus 9. Yeah, it's negative 20 minus 3 over, that'd be positive 25 minus 9. Negative 23 over 16. Let's round that. That's 1 point something. Negative 1 point something. Negative 1.4. So x is -5, y is negative 1.4. X is -4, 4 times -4 minus 3 over -4 squared minus 9. Hey, that's negative 16 minus 3 over positive 16 minus 9. That's negative 19 divided by 7. And that is along about negative 2.7. And negative 2. X is negative 2, so we have 4 times -2 minus 3 over negative 2 squared minus 9. Okay, that's negative 8 minus 3 over positive 4 minus 9. That's negative 11 over negative 5. And that's going to be a positive. 2.2? Positive 2.2. All right. Negative 2, I'm at positive 2.2. All right, a couple more. Do x is -1, so that'd be -1 squared. 4 times -1 minus 3 over -1 squared minus 9. That's -4 minus 3 over positive 1 minus 9. That's -7 over -8, which is a positive 8.75. Say 0.9. Okay, positive 2. Just plugging in some numbers. All right, this will easy. All right, so 4 times 2 is 8, minus 3. 2 squared is 4, so it'll be 4 minus 9. I get 5 over -5. That's -1 for 2. X is 4. 4 times 4 is 16, minus 3. 4 squared is 16, minus 9. Be 13 over 7, which is 1.9. Then when x is 5, last but not least, that'd be 20 minus 3 over 25 minus 9. Hey, that's 17 divided by 16. It's 1.1. All right. So I think that should give us some pretty good stuff to go off of. Let's put them up here. All right, so -5, I'm at -1.4. At -4, I'm at -2.7. -4, -2.7. -2, I'm at 2.2. At -1, I'm at 0.9. At 2, I'm at -1. 4, I'm at 1.9. And 5, I'm at 1.1. Since I have 2 vertical asymptotes, I've got 3 parts to this graph because the vertical asymptotes break the graph up. Always will. So I've got 3 parts. But again, the same thing. At each vertical asymptote, it either goes down on the left or up on the left, and down on the right or up on the right. What does it do on the left here of -3 vertical asymptote? Well, it looks like it's headed downward, doesn't it? Then on the right, these points go here, so on the right of -3, it looks like it's headed upwards, doesn't it? On the left of positive 3, well, connect these up, and it looks like it's headed downward, doesn't it? On the right of positive 3, well, these points seem to indicate it's headed up. So I've got down, up, down, up. That's what it looks like. Which just leaves me, is that okay? Which just leaves me the ends. Well, the ends, we know it levels off at the horizontal asymptote, which is 0. So these points seem to indicate it levels off like that. This point out here seems to indicate like that. With me on that. Now, this graph also brings up another slight little point. And that is, we said vertical asymptotes cannot be crossed. I didn't write it down, so I'll write it down now. That's always true. But look at this. In this case, do you see something happening on the horizontal asymptote? I've crossed over my horizontal asymptote. You can cross horizontal asymptotes. You won't always, but you sometimes can. So they're a little different. We know we get them differently, and they work a little bit differently. Horizontal asymptotes, you can cross those. We have an example right here. We crossed over this horizontal asymptote. Really, the horizontal asymptote just tells you about the ends. So for the horizontal asymptote, it doesn't really matter what happens here in the middle. And sometimes you will cross them. You won't always, but sometimes you can. But vertical asymptotes, you won't cross those. All right. Okay, let's, let me start at least, we should be able to do it. Let's do one more. One more of these nice rational functions. They probably the most complicated ones we've done so far. Would agree with that assessment of that if you were thinking that. All right, let's say we got f(x) equals 1 minus 6x squared divided by x squared plus 7x. All right, what vertical asymptotes you got there? Well, you set the denominator equals 0. Factor it up. Does factor here, x. Got a common factor of x, don't I? So factor off an x. We got x times x plus 7. Well, that sets up x equals 0, x plus 7 equals 0. So one of my vertical asymptotes is 0. What's the other one? Negative 7. Subtract 7. So I've got vertical asymptotes 0 and negative 7. All right, what about the horizontal? Well, if we go y equals a over b, I can do that one here. That is one of the reasons I did this one. What do I divide here for a over b for the horizontal? 1 divided by x squared? No. This is the leading term on the top, isn't it? Even though it's listed on top at the end, isn't that the leading term? Isn't this a second degree polynomial, if you will? So yeah, it's negative. The a is negative 6x squared. The b is just 1x squared. And so you divide those, you get negative 6. So that's going to be the horizontal asymptote way down at negative 6. So let's put those up here. All right, so we've got a vertical asymptote at x equals 0, which would be just the y-axis, and then negative 7. So, vertical asymptote. And then the horizontal asymptote's down at negative 6. Do a dotted horizontal line at negative 6. All right, my y-intercept, set x to be 0. 1 minus 6 times 0 squared over 0 squared plus 7 times 0. Well, that's 1. Since that's 0 over 0 plus 0, that's 0. What do you get if you divide by 0? It's not a real number, yeah. 1 divided, you can't divide by 0. That's, you got a vertical asymptote there anyway, so no x-intercept. No y-intercept, sorry. The x-intercept, well, that's a different story. You set f of x to be 0. Then to solve that, is multiply both sides by x squared plus 7x. Anything times 0 is 0. So the left side 0, the right side, the x squared plus 7x cancels, so I just have 1 minus 6x squared. And that's a nice little equation there. Let's move the 6x squared, add 6x squared to both sides. So I'm going to use the square root method here. Divide by 6. And so I get my x squared equals 1/6. Square root both sides, so I get x equals square root of 1/6. So it'll be plus or minus square root of 1/6, which is plus or minus not very big number. The square root of 1 divided by 6. It's 0.4. All right, so no y-intercept, and the x-intercepts are positive 0.4 and negative 0.4. Okay. All right, so a little table here. X values around the vertical asymptote. Well, got two vertical asymptotes. I got -7 and I've got 0. Those are my vertical asymptotes. So if I do x values around that, -8, -9. Let's do those. -6, -5. A couple more around those. Here, at around 0, we already got. So let's just do -1 and +1. See what happens. Okay. So -9, if x is -9, I have y equals 1 minus 6 times, -9 squared would be +81, -9 squared would be +81, 7 times negative would be -63, just to save us a little time here. That's going to be, well, it's going to be a lovely little number there. 1 minus, what was that, 486? So 485 divided by 18. Oh, that's a good number. I get to be negative 26.9. All right, then x is -8. That'd be 1 minus 6 times -8 squared is positive 64. 64 minus 7 times -8 would be -56. That's going to give me -383 divided by 8. -47.9. All right, at -6, I'll have y equals 1 minus, That'll be 6 times 36 over 36 plus, minus 42. So that's going to be negative 215 divided by negative 6, which gives you positive 35.8. At negative 5, we have 1 minus 6 times 25 over 25 minus 35. Let's see what that is. Negative 149 divided by, it'd be negative 10. Hey, that's positive 14.9. 2 more. All right, 1 minus, well, that'd be 1 minus 6 times 1 be 6. That'd be 1 minus 7. I'm plugging in negative 1, so it'd be negative 5 over negative 6. Which is about 0.8. And then last but not least, when x is 1, we'll have y equals 1 minus 6 divided by 1 plus 7. That's negative 5 over 8. Which is negative 0.6. Okay. All right. So if you believe all that, let's see what we got. Negative 9, I'm at negative 26.9. And then negative 8, I'm at negative 47 point, let's just say that's down there, at negative 8. At negative 6, I'm at positive 35.8. So this side, right, a little bit over there. And at negative 5, I'm at 14.9. Let's say that's right about there. At negative 1, I'm at 0.8, right there. And then at 1, I'm at negative points. Whoops, it's right there. And then negative 1, I'm at negative 0.6. Okay. All right, so these two connect up there. Like we said, at vertical asymptotes, it's either heading downward at the vertical asymptote or upward. This one seems to indicate it's headed downward at the vertical asymptote on that side. On the left side, connect these points up. That looks like it's headed upward there. Easy call there. All right. Now, on this, I've also got a vertical asymptote of 0, so I've got to think about it. Because on the left, it either goes down or it goes up. Well, I don't have any other points besides these, but these tend to indicate a general downward trek, doesn't it? So I think it's going to head downwards for this. We'll keep it going down there. Yeah, I think it's headed downwards there. And then these two connect up here, so it's headed upwards there. On the other side. Just leaves me the ends. What happens on the ends? Levels off at the vertical horizontal asymptote, which is negative 7 here. Get rid of this stuff. Extend this out a little bit because, yeah, these are going to come up and level off out here. These is going to level off like that. So this is basically the same. And when you get two vertical asymptotes, it takes a little more time, if you will, but basically the same for these rational functions. And that's about as complicated as we'll get. And I don't think I have more than 5 or 6 of those. No, those types. I think there's only a couple of those. So.